Welcome to the listening section of the TOEFL mock test, brought to you by Spinta. This section measures your ability to understand conversations and lectures in English. In this section, you will listen to several conversations and academic lectures. Each conversation and lecture is followed by a number of questions. You will hear each conversation or lecture only one time. You may take notes while you listen. You may use your notes to help you answer the questions. Some of the questions will replay part of the audio for you. Answer the questions based on what is stated or implied by the speakers. You must answer each question before moving on. You cannot return to previous questions in this section.
Good morning. Today we will examine how habitat fragmentation affects pollination networks and the ecosystem services that depend on them. Fragmentation occurs when continuous habitat is broken into smaller, isolated patches by roads, agriculture, or urban development. This process changes species composition and the physical environment in ways that ripple through ecological interactions. To understand these changes, I want you to think of a forest as a community of interacting species. Pollinators such as bees, butterflies, and hummingbirds do not only depend on floral resources. They also depend on nesting sites, microclimate, and movement pathways between patches. One theoretical framework that helps explain patterns after fragmentation is island biogeography. Islands here are habitat patches. Smaller and more isolated patches tend to support fewer species because colonization rates drop and extinction rates rise. Empirical studies show that fragmentation reduces pollinator diversity. For example, research in tropical forest fragments found fewer specialist bee species in small patches and a shift toward generalist species that can tolerate open or altered conditions. Fragmentation also alters interactions. Even if some pollinator species remain, their interactions with plants may change because of altered behavior, mismatched timing, or fewer interaction partners. Fragmentation reduces the number of pollinator species and alters interactions, so pollination services decline even when some pollinators remain. Several mechanisms drive these changes. Edge effects create drier, hotter conditions and favor edge-adapted species. The surrounding matrix can be hostile, limiting movement and gene flow. Small populations are subject to demographic stochasticity and inbreeding, increasing extinction risk. There are real-world consequences. Crops that rely on animal pollination, like many fruits and coffee, can experience reduced yields and lower fruit quality when surrounding natural habitat is fragmented. A study comparing coffee farms found that farms with nearby forest patches had higher pollinator visitation and greater yields than isolated farms. We can apply landscape ecology principles to mitigate these effects. Increasing patch size reduces local extinctions. Improving connectivity through corridors or stepping stone habitats facilitates movement. Managing the matrix to be more permeable, for example by promoting agroforestry rather than intensive monoculture, can help maintain pollinator communities. One case study worth discussing is shade-grown coffee in Central America. Farms that maintain native shade trees act as partial habitat. They support higher bee diversity and preserve plant pollination networks more effectively than sun coffee systems. This is a practical way to combine agricultural production with biodiversity conservation. At the scale of reserves, protected area design should incorporate metapopulation dynamics. Multiple reserves connected by corridors can reduce regional extinction risk more than a single isolated reserve of the same total area. Monitoring network structure is an emerging tool. Instead of only counting species, ecologists map who interacts with whom, Loss of key interactions can signal impending functional collapse, even if species counts appear stable. To conclude, fragmentation reduces biodiversity and alters ecological interactions. Conservation strategies that increase patch size, enhance connectivity, and integrate biodiversity-friendly practices into agricultural landscapes can sustain pollination services and the many human benefits they support. Next week, we will examine models that predict how network structure changes with species loss and how to prioritize species for conservation based on their roles in networks.
Listen again to part of the lecture. Then answer the question.
Fragmentation reduces the number of pollinator species and alters interactions, so pollination services decline even when some pollinators remain.
For more TOEFL mock tests, as well as IELTS and Cambridge practice, visit www.spinta.org. We provide updated tests every single day, AI feedback for your speaking and writing responses, and access to a wide range of high-quality mock tests to help you prepare with confidence.